For those of you that don't know very much about Mavenir, Mavenir is a disruptive company in the wireless space, effectively providing end-to-end mobility solutions. So Mavenir in its portfolio has every element in the network. And we're probably one of the suppliers that's provided the largest virtualized networks for IMS processing in the world. So as a reference, we supply all of T-Mobile USA's core IMS products fully virtualized. So it's great to be at a conference talking about automation and intelligence for virtualized networks. Mavenir was put together by Cirrus Capital about a year ago, and it brought together all of the messaging companies. I don't know if you remember, Zura was a company which really brought together all the messaging companies, and then put that together with Mitel Mobile, which was in the IMS space. And then one of the areas that I've been working on for Mavenir is the whole Cloud RAN access space. So really looking at virtualizing the whole radio network, apart from the radio itself. So, and I'll touch on some of that in this discussion. But part of the vision that we have is really that the network is moving away from a centralized core, and this has really all come about through virtualization. So I think if I make an attempt and jump in my slides here. Oh yes. Good, thanks. So apologies. So where we are today from a network perspective, and this goes back to the 4,000, 400,000 elements that you may have in your network. On the left-hand side is typically the representation of a mobile network with all of the individual elements. But in the past, they've all been delivered as discrete, customized hardware in a mobile network, and the vendors have really made money in terms of scalability of these elements from hundreds of thousands of subscribers to millions of subscribers. But the whole model, the money-making machine, if you like, for the legacy networks is about supplying more boxes, higher capacity, and higher throughput. Whereas in reality now, through virtualization, you can achieve the same result sitting on a standard COTS hardware platform. And from a Mavenir perspective, it's not just about scaling up. We supply some of the largest IMS networks in the world. But where we see this going is actually the VNFs have got to come down the other way, and you've actually got to be able to scale them down to run on 2 or 3 cores of a compute engine as you move to the edge of the network. And one of the things we've been doing with our partner Adva is looking at how we can orchestrate those platforms in terms of a zero-touch architecture to supply wireless services, right out to the edge, and including the enterprise piece of the network. So, the important message here is, in the future, it's all about the ability to scale down as well as scale up, and it's about distributed computing versus centralized computing. So, from a packet core perspective, in terms of, building the intelligence and building the automation, it's about, how do you move that core to the edge? How do you, reduce the scale of this in terms of cost and functionality, and really starting to address some of the points that were talked about this morning about latency and the ability to produce low latency services, right at the edge of the network, both from a user plane perspective and a control plane perspective. And in the process of doing that, build intelligence around that type of an architecture. And you may have seen that Mavenir actually purchased an intelligence company about 4 weeks ago, a company called Argyle, where we're looking at building security intelligence into our products as part of that process. So, from delivering low latency services to, reducing cost, and I'll talk about an application at the end of this presentation where, by moving that functionality to the edge, you can actually look at saving huge amounts of cost in terms of distribution of content in a mobile network that's actually, where the carrier today is actually not making any money on that content of the network. Split user plane, split control plane, that's very much a given in terms of the ability to scale the size of the user plane versus the size of the control plane. And then, and this all requires intelligence sitting around it in terms of how to make these things interact. Clearly you've seen this with sort of private IoT networks needing these sort of requirements, but the big thing here is that where we talk about network architecture for mobile networks in terms of RAN and the packet core, we're actually seeing these things really coming together now. Mavenir is actually delivering VNF virtualized radio networks into test now, and combining that with the EPC on single compute platforms. And again, this comes back to the scale of being able to do that. So hopefully there's a video here that shows an application of how we see this coming together. If you can start the video. So this is really one of the opportunities that's really been broken up by opened up by virtualization. I don't know how many of you have played around in the whole in-building wireless coverage space, but typically, everything we've shown in that 1-minute video would take 6 to 9 months, even to a year, to get an in-building LTE system put in place because of the ownership issues, demarcation, the frequencies, and all that, the other applications. But through virtualization, you actually be able to put the complete mobile network, including the packet core, right down into the enterprise. And say these, with Adva, we've been really focused at, how do we do this on a zero-touch basis? As you see here, from an enterprise market, SD-WAN, router, firewall are all services that are now being offered by the business enterprise, such as Verizon. And we question sort of, why can't I just add the BBU EPC part of that to that enterprise white box platform, and then have the ability to plug in over the Ethernet radio modules that essentially make that whole building then, as a private LTE network. And this is reality. We have these in the labs now where I can do this. Some of this has come about through the functions of Cloud RAN type technology, where the specifications are all changing now and opening up the radio interfaces between, what the radio that sits on the tower or the radio that sits in the enterprise to the compute functions. But, apart from that power amplifier and radio receiver, everything else now can be software within the radio network. So it's opening up a lot of new opportunities for rapid intelligence, SDN, and virtualization in there. And this is all based on, universal CPE equipment, white box platforms. But one of the big problems that's been in the whole DAS space is the ability for, if you like, the IT person to go and instantiate that network. And that's what's generally been taking the time. It's the fact that you've got to do surveys, you've got to have RF engineers go out there, and then it's got to be plugged back into the core of the mobile network. All of those issues are challenges, major problems for mobile carriers. And then last but not least, it comes down to who pays for it. Whereas, working this white box approach, and this is really, the model that we've been working with Adva, using the very thin orchestration software that comes from, the Ensemble business unit, is the ability to, put that on a 12-core compute white box platform, And then Dell, in terms of the second steps here, once you've got the thin orchestration system, you've got the order going to Dell for shipping the box directly to the customer. And then when that box is plugged in at the customer premises, the Mano system effectively, through secure codes, downloads the VNFs and starts to build the radio network. Now, there's one manual function that's got to go on, is the radio modules have got to be plugged into the Ethernet cables. But again, that's become like treating it like Wi-Fi in that sense, that you can really get LTE now into the premises and having it behave like Wi-Fi, treating it in the same way you would manage a Wi-Fi network. The Mano system is controlling essentially the VNFs that are downloaded, the connectivity back to the IMS if there's no IMS on the premise. But within hours, you can effectively set up a complete LTE network. And to the extent, from an operator perspective, there's no inventory to be handled. There's no truck rolls in terms of technicians going out there doing this stuff, and then immediately getting to revenue as quickly as possible. And we're seeing this new business model effectively in the US coming out of the whole CBRS. There's a unlicensed piece of spectrum that's being auctioned, and some of that's being discussed in Europe. But this model can be used both for unlicensed spectrum and licensed spectrum as a way of now really putting out as a managed service the ability to provide wireless networks. So we're quite excited about the fact that through virtualization, through automation, you can really use the zero-touch process in not only the core elements of the network, but right out to the edge in the enterprise. So, the terminology that we've sort of really been pushing is, look, build your own network. And we're going to see a lot of this coming out in the future, that because of the numbers of unlicensed networks that are really going to come out there, you've got to make this simple, easy, and cost-effective for deployment. So, again, it's all about, scaling of VNFs, making them as small as possible, zero-touch deployments, and then, last but not least, the enterprise actually being able to pay for that service, whereas today, obviously, it's really pushed back on the mobile carriers to build and fund that coverage that will go into those networks. And this has got a lot of other added benefits in terms of security, the ability to keep all the private information in-house rather than going off into the mobile networks. So, again, once you have that compute platform in there and you're treating it like an IT function, I've got my mobile network, I've got my IMS network, I've got my voice network, and running my applications internally without having to go out onto the mobile carrier. So we're all quite excited about some of the developments that are really coming out of this whole zero-touch deployment process. So another application that I'll talk about here is by moving the core to the edge, looking at offloading of data, the operators can start to really get benefits in terms of cost savings against the conventional architecture. And this slide here is a typical example. The blue line here is, if you look at a cell site, for instance, and say, okay, what is the capacity growth that's coming over the next 5 years? You see the top blue line, and this is allowing for new cell site growth and building new cell sites. And you say, look, if I can offload a percentage of my video traffic, and today 80% of the traffic on a mobile network is video. And that video, the mobile operators are making very little money on that, and 40% of that video traffic is encrypted. So there's even more that they can't actually get access to it. So to that extent, if I can offload, in this example, we use 32% of the traffic, and offload that as close to the cell site as possible, then I can actually push back my core investment by 2 years. And so that's actually a huge cost saving to a mobile carrier in terms of, core deployment and then transmission deployment that sits behind it. So again, this is all coming back for the fact that I can really now take my core and push it really to the edge and treat it as a distributed compute network. Okay, so that's all I got to talk about. Any questions?
And how do you handle interoperability with basically operators' network, or do you handle that, and how automatic that part is?
Yeah, so clearly we're relying on standardization for interoperability, and this has always been a challenging area where in the current mobile networks today, there is no interface spec between the radio and the baseband control unit. So one of the things that Mavenir has been doing is working with a standards group. Actually, it's not listed up here, but XRAN is another group that's out of Stanford University that's really doing the interface specs between the baseband controller and the radio units, and there's 2 projects running in there, and those specs will start to come available at the end of this month in terms of openness of those specs. And Mavenir's goal is to get all these specs fully open so that you can fully interoperate. And there's another set of specs around the controller where today you can't actually do a handoff between 2 mobile networks in the same area. And that's why carriers are building networks in regional areas, and you may actually drop a call between the networks purely because of the way that the garden walls have been put up around the standardization process. So standardization is very important. Open interfaces is very important. But there's energy in the industry now to get innovation back out there and get some of these specifications open, and we firmly believe in that, and happy to work with anybody and help promote that whole base of getting the technology to the right place where operators have a choice.
Could I ask you to expand on what you said towards the end of your presentation, that you could reduce core investments by 2 years if you could steer the traffic locally. So what does that mean? Does that mean that you're going to put some intelligence in the cell site so they can do things like application-aware steering? Is that going to be remote from the cell site? I mean, how do you see that working?
No, our vision is that that's all sitting at the cell site, and today you can do application routing based on what's called APN routing of a specific application. So a carrier can actually set up an APN route against Netflix or YouTube or Facebook, and then they would automatically route. But you're right. This is opening up the opportunity to put some AI around those applications and watch what's coming out of the user interface. One of the operators we're talking to actually wants to put all the top 10 videos sitting at the cell site, because the majority of what people do is actually look at the same set of videos. If you go to India, for instance, one of the operators there is saying, look, the biggest burden of video traffic on my network is when in a cricket match somebody scores a 4 or a 6. The majority of people just go and look at the 4 or the 6 all the time, and so if they could cache that piece down into the edge of the network, it would save all that burden of traffic going back through the network. And what we're seeing is a lot of the network is still built on a very hierarchical basis where, you've got a lot of redundancy in the cell sites, go back through the core. But then, right at the top of the hierarchy, you've got basically 2 points of interconnection to the internet. And essentially all the traffic is going back right the way back through the core of the network. So, what I talk about here really is, you can put this breakout at the cell site or any other point of internet interconnect to make it cost effective before you get to the packet core. The whole goal is to take the strain off the packet core, reduce latency, and put some of the content where it really is needed.
For example, for the stadium case that you were mentioning, that people want to see a same video like for the last 5 minutes, yeah. Did you already thought how to solve the problem when several operators are providing this connectivity in a small cell, for example?
Yeah, so this comes back to network slicing and how you could slice the networks, and you can also do it at a radio level as well. At Mobile World Congress, I think there was a demo again with our colleagues Adver that they were showing full network slicing off of a common RAN. So you've got the ability to use these private networks in a shared way. Given that today pretty much the technology everywhere now, and including in the US, has gone to LTE, you can use a common carrier. You don't have to have 4 separate base stations for 4 separate carriers. And by having software sitting there as a DMARC at the edge of the premise, then you've got the ability to set up roaming mechanisms at an EPC level or even at a full network level to roam between all these different carriers. So, I think, the message really is, look, you've got all these network architectures today, you've got all these business models, all the ways to roam, etc. Think about sharing hardware, sharing resources, and then set up the roaming capability or the ability to share services through business agreements, and instead of building separate networks. All right, thanks.
Thank you, John.